Well, what's the date? Tell me the date, folks. I did change it. Thank you. I guess I only got one kid in class. Welcome. And today we're talking about 5 is half of 10, which you obviously all know already, but this is a strategy. 5 is half of 10. And if we put 10 times 26 on here, we're going to use several strategies here, kiddos. 10 times 26. And let's solve this using which strategy? Guess which strategy we're going to try first. Revel. Wrong. We're going to try a ratio table. Good guess, though. Draw your line. Remember ratio tables, folks. We're going to use them a lot simply so you don't forget about them because they are very helpful. Now, if we're trying to find 10 26s, where would be a good place to start? 1, very good. If we're talking about boxes of baseballs, if we have one box of baseballs that cost 26 bucks, I like to attach meaning to these words. So 10 boxes, $26 a box. Let's find out how much 26 boxes cost. Elian, since we know 1, what would be a good thing to do now? If we're trying to get to 10, what? I like 2. So let's draw what we need. Doubling symbol times 2, and we get 2. And down below, times 2, 26 times 2 is what? Anybody? Trevor. 52. Very good. Now from here, what options do we have? 1, 2, several? What options do we have, Aubrey? What do you think? We figured out 1 box and 2 boxes. We could do 4. Let's do 4. Just to see. So we double on the top. That means we double on the bottom. Whatever we do on top, we do on the bottom. So double 2 to get 4, double 52 to get. That's a time of day. 104. All right, I'm going to trust you on that one. Now we could keep going by what? Keep climbing up by what? 2s. Or we could do what? We could do 4s. I mean, double by 4? So 4 times larger? What's 4 times 4, though? That'd be 16. We're trying to do 10. So we wouldn't multiply by 4. We could do 1 and 4, right? What could we have done from 1 right off the bat to figure out 10? Just because it's a nice number, Don. Well, we're talking doubling or adding. What would you done? If we know 1, what should we try so we can get it done in one felt swoop? Times 10, someone said. Yep, 1 times 10 gives us 10. And 26 times 10 gives us what, everyone? 260. Thank you, everyone. So in this particular one, we could have got it done in one move because 10's a nice round number. It's a multiple of 10. But we did 2 and 4 to show you that you don't have to. You can go as slowly as you want. You can go up 1 at a time if you want. But if you want to get done, do as much as you can. Any questions about that one? All right, draw your separation line. Try this one. And while you're writing the problem down, think, how's the first one going to help us with the second one? How will the first one help us with the second one? What do you think? We had 10 times 26. Now we've got 5 times 26. How is that going to help us, Hallie? Sometimes. Any others? Oh, yeah. What? Say it again. They halved the 10 to have 5, right? And they kept the 26. So keep going. What's that mean? We don't even have to do really much work here. We don't even have to multiply. What can we do? She's right. With those facts, what does that mean, Elian? 26 plus, oh, right. You mean from the first thing?
Yeah.
Yes, we could. You're right. We could add the one group and the four groups to get the total. That's right. What's another way? Fensky. Half the 260. Remember, we talked about this earlier. If a product grows by 2, then if we double a factor, we double the product. But this time we halved the factor. 10 is half of 5, so that means we can just half the product. To do that, let's try this though. Someone mentioned something. Oh, we could do this. No, let's not do that. Let's try this. So 5 times 26. Let's show what we just did. 10 times 26. What did that equal? What did that equal? Just say it. 260. And then if we half 260, halving it means what operation, Zach? Dividing by 2. 26 divided by 2 would be what? 130. 26 divided by 2 is 13. And just add your 0 to it. Watch in your math. If you have a 5, see what you did just before it, either on the same page or a different page. All right, let's do one of these just for some practice. Draw your separation line. We talked about this yesterday. Let's do 12 times 39 using our partial products the way we talked about it yesterday. Not with the frames and arrows, but with real partial products. So I like to put the bigger numbers on top, smaller number on the bottom. Do we have to do that? No, because multiply can do it in any order. Can anybody give us the first thing we're going to multiply, the first values? What are we going to multiply first on this one? What do you think? Kara? What? Well, we're multiplying 12 times 39, but which values are we going to multiply? Chase, what do you think?
9 times 2.
Nope. Could we?
Yeah.
Yes, but that's not what we talked about yesterday. Slinky?
30 times 10.
Yes. I like us to start with the largest values. And you notice he said 30 times 10 because this is 12. 12 is made of 10. 39 is made of 30. So 10 times 30 is what? 300. You can put it right there. You can put it here also if you want. After 10 times 30, then what do we do? See what you remember from yesterday, Fitch?
9 times 1.
Not yet. No, that's not a 1 though.
Oh, 10.
10 times 1, yes. Once we start with the 10, we finish with the 10. 10 times 9? 90. So we just did the 10 times both of these numbers. Now we're done with that 10. Now we're moving on to which number, Chase?
2.
The 2. And this is a 2 because it's where? In the ones. So 2 times what, Clara? 2 times 30, or you could write 30 times 2. That's up to you. What's that equal?
60.
And then 2 times 9 equals 18. And then we're done, right? No. What do we do next then, Trevor? No, we don't. Add them who? Oh, add them up. Oh, okay. Let's add them up. What do we get? What do we get? Close.
468.
468. There's no ands in there, ns or anything like that. Partial products, folks. Write that down in case you forget again. If you're looking for partial products information and you're paging through your math journal, it's right there, the 5th of October.